We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Now see, in this lecture, we have discussed the new topic which is known as derive the electric field due to the infinite line charge. Derive the equation of electric field intensity due to the infinite line charge along the entire z-axis. Means what? See this. See this. This is the mouse of cursor. Derive the equation of electric field intensity due to the infinite line charge along the entire z-axis. Along the entire z-axis. This is the entire z-axis at which plus q charge can be distributed. Plus q charge can be distributed along the entire line. Now, due to this plus q charge distribution, see this. Due to this plus q charge distribution, we would like to determine the electric field at P point. We would like to determine electric field at P point due to this plus charge q charge distribution. Now, charge distribution on the entire line. Now, due to this particular line, we want to find magnetic electric field at P point. Now, see this electric field that can be located in the xy plane. Due to electric field that can be located in the xy plane. See this. So for xy plane, z coordinate is 0. See this here, z coordinate is 0. Z coordinate is here is 0. So here it can be considered as a r comma phi comma 0. R comma phi comma 0, and here we can consider 0 comma phi comma z. Why? Because it can be considered as a cylindrical coordinate system. So P point that can be located in the xy plane. P point can be located in the xy plane. At this point, we want to determine electric field. At this point, we would like to determine electric field. See this. So cylindrical coordinate system Q point is determined as a 0 comma phi comma z taken to as a fact phi. So P of r comma phi comma 0 and Q of 0 comma phi comma z. So ideally at z axis 0 comma z, but for it is limited only for Cartesian system, but for cylindrical coordinate system 0 comma phi comma z. So dq equal to rho L dl. Rho L means what? Line charge density. Rho S means what? Surface charge density. Rho V means what? Volume charge density. Charge distributed per unit line. It is known as line charge density. So dq equal to rho L dl. So dl equal to dz. So electric field intensity due to the point charge dE equal to dq divided by 4 pi epsilon 0 r square in the direction of AR. So dq equal to rho L dl divided by 4 pi epsilon 0 r square, vector r divided by magnitude of r. So vector r equal to r comma phi comma 0. Why? Because electric field generated at P point minus electric field generated at due to the Q point charge r comma phi comma 0 minus 0 comma phi comma z. So here RAR minus ZAZ. So here it is known as under root of R square plus Z square. So magnitude of R square equal to R square plus Z square. Here rho L dl in the bracket of RAR minus ZAZ divided by 4 pi epsilon 0 R square plus Z square raised to 3 by 2. See here it is considered as a magnitude. See here it is considered as a unit vector. So RAR minus ZAZ divided by R square plus Z square raised to 3 by 2. So here it can be considered as a R square plus Z square raised to 3 by 2. Now, due to point charge, if this charge distributed along the line, then it is known as line charge. Then it is known as line charge distribution. So E equal to minus infinite to infinite dE. This is 0.4 line charge. So rho L dz divided by 4 pi epsilon 0 R minus Z Az divided by R square plus Z square raised to 3 by 2. Now see this. At this point, we would like to determine electric field. See this at this point. So here plus Q charge. So due to this plus Q charge, electric field can be present in the outward direction. See this outward direction. And here plus Q charge. Here also field can be depends on vertical direction. Here field can be depends on horizontal direction. See this particular direction. See here it is particular direction. So vertical component can be cancelled with each other. Only horizontal component can be present. Vertical component cancel with each other. Again repeat, electric field here due to this plus Q charge, electric field can be considered as a downward position. અહીંયા જે plus Q charge હશે due to this charge, electric field is downward position. Here due to this plus charge, bottom charge, electric field is in upward position. So vertical component cancel with each other. Only horizontal component can be present. Horizontal component can be present. So here minus infinite to infinite, rho L dz, R A R, vertical component present, absent, vertical component is cancelled. So see, this is the component that can be cancelled. So only this component is present. So here it is known as R A R minus Z A Z, R A R, R A R, rho L dz upon 4 pi epsilon 0, R square plus Z square raised to 3 by 2. Z equal to R tan theta. So dz equal to R sec square theta d theta. So z tends to minus infinite. So theta tends to minus pi by 2. Z tends to plus infinite. So theta tends to plus pi by 2. So minus pi by 2 to plus pi by 2. Rho L R sec square theta d theta into R A R divided by 4 pi epsilon 0. R square plus R square tan square theta raised to 3 by 2. 4 pi epsilon 0 R cube 1 plus tan square theta raised to 3 by 2. So 1 upon sec theta, 1 upon sec theta equal to cos theta. Integration of cos theta is sin theta. So here we can say rho L divided by 2 pi epsilon 0 R in the direction of AR. This is the final equation which indicates electric field intensity generated due to the line charge. Electric field intensity decreases with distance increases, at which we want to determine electric field. Means what? Means what? If plus Q charge, say this is the plus Q charge, say it is plus Q charge, say it is plus Q charge. If this charge can be distributed in the line, and if we want to if you want to find electric field at P point, so if P point is distance, if P point is increase the distance, try to increase the distance, then field is decreases. See this inversely proportional. See this graph is inversely proportional. Means what I am trying to say, if you can sketch this graph, then see this, then see the graph at R equal to 0, then infinite field. But if distance is increased, then graph can be decreased progressively. E inversely proportional to 1 upon R. See this. E inversely proportional to 1 upon R. See this. If line charge distributed along the y-axis, then no component present on y-axis similar for x. So it is known as inversely proportional to R. See this. This is known as electric field due to the infinite line charge. Rho L divided by 2 pi epsilon 0 R in the direction of AR. So now we have calculated the example. like to calculate the example based on the electric field due to infinite line charge. See this. Uniform line charge density 20 coulomb nanocoulomb per meter lies on the z-axis between z equal to 1 to z equal to 3 meter. No other charge is present. So determine electric field at origin first of all. So we would like to determine electric field at origin. Charge distributed on the line, that line start with z equal to 1 to 3. So line charge present in only z axis. That's why we can consider as a 0, 0, z. It is 0, 0, z and 0, 0, 0. So minus z az. So here under root of r equal to z. Why? Because if you can take the determinant of this, so we can get z. So mod r square equal to z square. See this. See this, it is known as z square. So dq equal to rho L dl divided by 4 pi epsilon 0. R square equal to z square. Here minus z az. So z cancel. So 1 upon z square. Now if you can take integration from z equal to 1 to 3. So here all the term can be considered as the outside term. Why? Because all are the constant term. See this, all are the constant terms. So it can be considered as the outside. So 1 upon z square. What is the answer of 1 upon z square? 1 upon z square, which is equal to minus 1 upon z. So minus 1 upon z, z equal to 1 to 3. So it is the correct answer. 0.1199 into 10 raised to minus 3 volt per meter. It is the correct answer. Determine the electric field due to the infinite line charge. Determine the electric field due to the infinite line charge. So it is the answer related to electric field. Now similar for determine the electric field at 4, 0, 0. So here 4ax minus z az. So here z square plus 16. So here we can say z square plus 16 you can solve this equation. Then we can get this particular answer. So it is considered as a, we have find this particular answer. Second integration, first integration, and then we can add with each other. So we can get this answer, final answer. I would like to solve this example, but you can try by yourself based on the previous one example, similar type of example that can be present. See this DE. DE we can get this. Now if you can take integration, so for z dz ax divided by z square plus 16 raised to 3 by 2 minus z equal to 1 to 3 z dz az divided by 16 plus z square raised to 3 by 2. Put z equal to 4 tan theta. So dz equal to 4 sec square theta d theta. So here we can say theta equal to 36.86 degree. 36.86 degree theta equal to, and theta equal to 74.036. So cos theta d theta. So 16.1. Solve the second integration. If you can solve this second integration, then we can get the another answer, which is known as 88.99. So it is the final answer related to electric field. So it is the concluding part related to example of electric field using the line charge equation rho L divided by 2 pi epsilon 0 r. Electric field generated due to line charge. Thank you very much.